Hi, this is Frank McBride, and I'm here with Catherine and Josh, and we're going to be presenting our pet feeder design project, which is RFID enabled and super smart.
Yes. Okay. So our design concept for the pet feeder was mainly to implement a level of autonomy to our feeding process for the pet. And we do that by using the RFID tag on the pet's collar when it would be red when the pet approached the food dispenser. So if the parameters were met and the pet has not had their allotment for the day and the time is appropriate, then the pet feeder will dispense the food into the bowl. So that was our main concept of the pet feeder, and these are the components we use, which were the Arduino Uno, RFID reader, continuous mode rotation servo motor, and the DS3231 RTC. For the Arduino Uno, we basically just used it since it was the most general board you could use without having to worry about tinkering. You could tinker without it being like worrying about what goes wrong. And so the Arduino Uno is basically a microcontroller board, which was based on the ATmega 328P, and it has 14 digital input output pins, 6 analog inputs, and 16 megahertz ceramic resonators. And now we use the RFID reader and tag, which stands for radio frequency identification. So basically it is a wireless non-contact use of radio frequency waves to transfer data. And so the RFID tags allow users to automatically identify the tags with the reader. And then the reader and tag was used to detect when the pet would get near the pet feeder, basically. And then
this is the continuous rotation servo. This servo is what rotates forwards or backwards instead of moving to a position. This is what we use to open and close the opening for the food to drop into the pet's bowl so that they would get their allotted amount of food at the proper time rather than them just always being able to get to it. This is the DS3231. This is a real-time clock module. This is the module that is used to measure the passage of time, and it's what we use to ensure that the pet feeder would dispense food into the bowl of the pet at the proper times. This way the pet wouldn't get it too late or too early, or it would know to feed it only twice a day rather than multiple times a day. The specifications of the design that we wanted. The device is programmed to dispense food twice every 24 hours when prompted by a successful tag reading. The timer is reset at midnight. This way we can tell like it's a new day rather than like not feeding the dog again. Dispensation or pet. Dispensation is around 1.5 cups of kibble, but can be adjusted in the code. Future incarnations can be implemented with an LCD button shield to adjust feeding sizes and possibly other parameters.
Hey, I'm going to be going over the code. It's relatively simple as far as code goes, but basically we start off with all our headers. We define the pins for the RFID right here, which ones are going to read. And there's the declaration of your module and the servo and the real-time clock, which are assigned to the SDA or SCL, which we use to like A4, A5 for. Same thing with liquid crystal. We use the I2C interface instead of all the bird's nest of wires that usually requires LCD screens. All this stuff is just set up for the display, either on a serial monitor or on the LCD itself. As you'll see in the demonstration, the screen displays the current time and how many times the feeding has taken place that day using a variable here called counter. So when we get into the nitty gritty of it actually functioning, we create a time variable of t, which is within the real-time clock header, it collects all the data for the current time. Then here is where the parameters have to be met, or for the reset. So when the hour, minute, and second are all 0, i.e. midnight, then the counter resets to 0. Otherwise, this is the functioning part of the code where it looks for new tags. Make sure that it is the correct one. And if it is, then it will run the dispensation. Right here is actually where it matches the code for the particular tag that I gave for the dog. And at that point, it was very interesting and very challenging to figure out the difference between regular servos, which operate on degrees, and continuous rotation servos, which operate on a time increment. That's what we meant by the amount of food being dispensed, being controlled on the code, is actually just the amount of time that the servo is allowed to spin the butterfly valve. Other than that, if the tag doesn't match, then there is a message displayed on the screen that there is no food for that particular pet. Hi, so this is the demonstration of the pet feeder. We're going to go over the different components. So right there is the servo motor that turns the dispensing wheel. Here up close is the clock and the number of feedings. There's your Arduino, obviously, and then there's your I2C interface. And the RTC clock, the DS3231. It's got it running on battery power just so it's away from everything else. And down here below is the RFID reader. So we're gonna try and focus here. Okay, we got a good image, and we're going to dispense the food. It's a little wild, but you can see that it's had one feeding today. We'll give Maggie a little more food. Now, as you can see, it was limited to the 2 times a day. And if you go down here and try and do the RFID again, it won't do anything until it reaches midnight again. That should be a pretty good demonstration. Hope that you enjoyed it.
Okay, so conclusions and results. So overall, our results for our prototype was a success. We were able to make a functional pet feeder with our automated feeding with the authorization of the RFID tag and reader, with also the dispensary of 1.5 cups of kibble to ensure that our pets would not go hungry. And yeah.
We had a lot we wanted to do to improve with it, but we couldn't get to it all with the time constraint and resources constraint. But some future incarnations can be implemented with an LCD button shield to adjust feeding sizes for your pets so that you can give them a little bit less or a little bit more. And we really wanted to increase the range of the tag reader so that you wouldn't have to have your pet putting their head so close to it, that they could have a little bit more leeway. And the structure itself of the pet feeder was made of wood, and we thought it would be better to have a 3D printed structure or something, just anything that could be stronger and a little nicer to look at. And then lastly, we wanted the ability to identify multiple different pets with different identifying RFID tags. That way, if you have like 2 or 3 dogs you can have them all fed at separate times, and one dog wouldn't be able to steal the other's dinner and stuff.
All right. Thank you very much. Just the last slide is going to be a few of the tutorials that I kind of based the project on and got the how-to. And that's it.
Yay.
Yeah.